This session, we are going to learn about line drawing algorithms. So, what is a line? It is the path between two endpoints. So, any two endpoints are connected by a line. So, any point, say x comma y, on the line must follow the line equation. What is the line equation? Y is equal to m into x plus b, where m is nothing but the slope of the line and b is a constant that represents the intercept on y-axis. The Cartesian slope-intercept equation of a straight line is given by y is equal to mx plus b, where m is slope and b is y-intercept. If you have 2 points, say x1, y1, x2, y2, which forms a line segment, we can determine the slope m and the y-intercept b with the following calculations. So m is nothing but difference between y2 and y1 divided by difference between x2 and x1. Similarly, the y-intercept b is obtained with this equation, y minus y2 minus y1 divided by x2 minus x1 into x. At any point xk, yk, this yk can be represented as m into xk plus b. Normally we had y is equal to mx plus b. Now this y is equal to mx plus b is with reference to the point x comma y. If you have any point xk comma yk, then the slope intercept equation of that line can be given as yk is equal to mxk plus b. Suppose if you are dealing with another point xk plus 1 and yk plus 1, in that case yk plus 1 is equal to m into xk plus 1 plus b. So subtracting 2 from 3, these two equations, we get yk plus 1 minus yk is equal to m into xk plus 1 minus xk. Here this yk plus 1 minus yk is increment in y as corresponding increment in x. So we can frame an equation. This yk plus 1 minus yk can be represented by del y and xk plus 1 minus xk can be represented as del x. So we can rewrite the above equation as del y is equal to m into del x, and thus m is equal to del y by del x. If you have two endpoints, say x0 comma y0, x1 comma y1, then the slope of the line between these 2 points can be calculated as m is equal to del y by del x, which is nothing but y1 minus y0 divided by x1 minus x0. To draw a line, we can use two algorithms. One is DAA algorithm, other one is Bresenham's line drawing algorithm. DDA, the expansion of DDA is digital differential analyzer. So in this session, we will learn this DDA algorithm first, and in the next session, we will be learning about Bresenham's line drawing algorithm. Coming to DDA line drawing algorithm, this is actually an incremental algorithm. We are going to increment the value of x and y and find subsequent points for x and y, and finally we will join those points to get a line. So this digital differential analyzer, it is a scan conversion line drawing algorithm based on calculating either del x or del y. We know what is del x and del y. Del x is nothing but x2 minus x1 and del y is nothing but y2 minus y1. So we have seen this equation, del y is equal to m into del x. We sample the line at unit intervals in one coordinate and determine the corresponding integer values nearest to the line path for the other coordinate, meaning we will be incrementing either x in unit intervals, like when x is equal to 5, next time x will be 6, the next time x will be 7, 8. Like that, we will be incrementing x coordinates alone in unit intervals, and then we will be finding out the corresponding y values for that particular point of x. So that is why we call this as an incremental algorithm. So incrementation can be done either along x coordinate or along y coordinate. So let us first consider a line with a positive slope. For m less than or equal to 1, if the slope is less than or equal to 1, we sample x coordinate. So that means we will have del x as 1 and we will compute each successive y coordinate. So always when m is less than or equal to 1 and when we have a positive slope, what we do is, see, this is evident from this diagram. Always we will increment the value of x from this point to this point, and then we will be calculating the values of y for this particular point of x. Then for this point will be calculated by incrementing x by 1. This point will be calculated for this x1. So we will have x incremented by 1 always, and for that value we will be calculating the corresponding y value. So how will we calculate the corresponding y value? With the help of this formula. So the new y value will be old y value plus m. M is nothing but the slope. Here k takes value from the starting point and increased by 1 until we reach the final point. So m can be any real value between 0 and 1. So slope value can be between 0 to 1. Suppose m is greater than 1, that is positive slope. We compute y coordinate, that is del y is equal to 1, meaning y value will be always incremented by 1, and we will calculate the corresponding x values with the help of this formula. So y value will be always equal to 1 and x is calculated by using old x value plus 1 by m. So in the previous state we have seen when m is less than or equal to 1, x was incremented by 1 and we will find the corresponding value of y. Now when m is greater than 1, y is incremented by 1 always, and we will be finding the corresponding values of x. So the above equations are under the assumptions that the lines are processed from left to right. So always, even in the previous diagram, we have seen the processing of line from left to right. That is, left will be the starting point. If the processing is from right to left, that is from this point to this point, then we will have del x as minus 1. We will be decrementing x value regularly by 1 and we will be calculating the corresponding y values, or else we will be decrementing the value of y always by 1 and then find out the corresponding values of x. So we have seen so many equations. So those equations will deal with positive and negative slope as well. So you will get a clear picture of 4 different cases. Case 1, when you have a positive slope and when you are moving from left to right, if the slope is less than or equal to 1, then you will have x incremented by 1 always and y incremented with m always. Suppose if the slope is greater than 1, then x is incremented by old value of x plus 1 by m and y is always incremented by 1. Case 2, we have a positive slope and if we are going to draw the line from the right to left, then we will be considering this value of slope. If the slope is less than or equal to 1, then x is decremented by 1 always and y is decremented by m always. If the slope is greater than 1, then y is decremented by 1 always and x is decremented by 1 by m. Case 3, we have negative slope and the direction is from left to right. In that case, if the slope is less than or equal to 1, then x is incremented by 1 always, y is decremented by m. If the slope is greater than m, then y is decremented by 1 always and x is incremented by 1 by m. And the last case, case 4, here negative slope but the line is from right to left. If the slope is less than or equal to 1, then always x is decremented by 1 and y is incremented by m. When m is greater than 1, then y is always incremented by 1 and x is decremented by 1 by m. So, with all these 4 cases into consideration, they have framed an algorithm for DDA. So, in this DDA algorithm, you will have two endpoints, x1 and y1 and x2 and y2. So, this is the starting point and this is the ending point. Between these 2 points, we need to draw a line. So, the first step that we need to perform is we have to identify del x, del y or dx, dy, steps and k. So, how to calculate this del x? Second point of x minus the first point of x, that is x2 minus x1. dy is calculated with y2 minus y1. Then whichever is greater, either dx or dy, that will be assigned to steps. We need to take only the absolute values. You need not worry about the signs, positive or negative signs. You have to consider only the absolute values of dx and dy. And whichever is greater, if dx is greater, then that is assigned to steps. If dy is greater, then that is assigned to steps. So steps here denotes how many number of steps we are going to have do the calculations to calculate the intermediate points from the starting point till the end point. Then we need to increment the value of x or y. So what value we are going to increment? That is given by increment x and increment y. So increment x is dx by steps, increment y is dy by steps. So initially our first point x1 will be taken as x and y1 will be taken as y. Every time we will finalize the next point by using this round off function, round off x, round off y. So if we get above 0.5, we will be rounding it to the next digit number, right? So if it is 1.5, it will be rounded as 2. If this is 3.5, it will be rounded as 4. So that rounding off function will be done. And the third parameter 1 is the color parameter. So we are not bothered about that. Next, what is this k? How many times this calculation is going to happen? So when k is equal to 1, we are starting with the first point, that is the starting point. And how long this will execute? Steps. We have calculated steps here. Absolute value of dx and absolute value of dy. Either this or this. So that denotes the number of times we are going to calculate the intermediate points. So how we are going to calculate the intermediate points? Old value of x plus increment of x. Old value of y plus increment value of y. Then again we will be rounding off the value of x and y to get the new point to be plotted. So hope you understand how the line is drawn by using the line drawing algorithm. You will get a better idea when we solve more examples. So here is an example. Before going to example, this DDA algorithm is fast method for calculating the pixel position than direct use of line equation, but there are some disadvantages as well. Number one, you need to round off every time. So that round off error in successive addition can cause some pixel position to have some wrong calculation which actually deviates from the actual line path. So instead of 2.5, if you are rounding it to 3, then there will be some slight deviation in the actual path. So that is one disadvantage. And then the second disadvantage is when you round off, you do some floating point arithmetic and it is time consuming as well. So these are the disadvantages of